Hello and welcome. So in today's video, we're going to be going over some free response problems from past AB calculus exams. So the big thing about AP calculus is, for the exam specifically, is 50% is dedicated to multiple choice. I can't really work any multiple choice problems. Those are kept highly safe, is the way that I'll put it. But they release the free response problems every single year, and this provides a great review opportunity. In many cases, I will argue that free response questions are a lot harder than the multiple choice section of the exam. And even though you can almost get you can get a 4 if you get 100% on the multiple choice, you still have to put some work towards the FRQs if you want to get that 5. So I want to kind of show you how you should be playing the FRQ game for the AB calculus exam. So we have the 2024 free response problem. This is question 1. So on this question, you'll be allowed to use your calculator along with my next video, but after that, I'd try to steer against it. I'd recommend you try to work out these problems yourself. And then here in a moment, I'm going to go through how I get my answers and that kind of stuff. Alrighty. So the temperature of a cup at time t is modeled by a decreasing differentiable function f, where f of t is measured in degrees Celsius. For 0, less than t, less than 12, select values of c of t that are given in the table shown. Approximate c prime of 5 using the average rate of change, or change in c, over the interval 3, less than t, less than 7. Show the work that leads to your answer. Include units of measure. So this is really just a change in y over change in x problem. So, however, in this case, it's not change in y, it's change in degrees Celsius over change in time, in minutes. So, we go and we want to know the average value for c prime of 5. So we're going to approximate that using 7 and 3. So we know for times 7 minus 3. On the top, or then for a value of 7, that's 69, and our value for 3 is 85. So we get 69 minus 85. Now these are all in degrees Celsius, and these are all in minutes. So what we're going to see here is, if you punch this into your calculator, which I highly recommend you do, just saves you some time working out the arithmetic, we get a negative 4 degrees Celsius per minute. Now, it's important that you include units, especially if it's specifically asked for, like include units of measure in your answer. Now we want to use a left Riemann sum for b, and with 3 subintervals indicated by the data set, so we'll be using the left endpoint of these 3 intervals. Okay, to approximate the value of the integral from 0 to 12. And then we're going to interpret the meaning of 1/12 times by the integral from 0 to 12 c of t of dt in the context of the problem. So, in this case, b, I'm going to probably move b a bit up because it actually has quite a bit of work to do. So, b, we are going to get 100, which is the endpoint of the first interval, times the left endpoint of the first interval, times by the width of the interval, which is 3. Then we're going to get 85 times by the width of the second interval, which in this case is 4. Then finally, we're going to get the 69 times by the width of the final interval, which is 5. So we get 69 times by 5. And this is going to be the approximate value, and I'm going to actually move this over just so the quote-unquote AP graders might be able to see a bit more of my workflow. Integral from 0 to 12 of C of t is equal to this shish kebab. Also, remember your DTs, however, it won't be graded on the exam. So, plugging this into your calculator, we get 300 plus 85 times by 4 plus 69 times by 5. That gives us a value of 985 degrees Celsius times by minutes. Now you might be asking, why am I including units here, and where do I get these units? Well, the temperature is in degrees Celsius, and these width of intervals are in minutes. We're multiplying them, so we're getting the unit degrees Celsius times by minutes. Now for the average value, we're going to multiply that by 112, so we get 112 times by 985. This interval is in minutes, okay? And this is in degrees Celsius times by minutes, so the minutes will cancel. Now we're going to get 985 divided by 12, and that's going to be equal to 82.083 degrees Celsius. Now we're going to write down the interpretation for this. So so we get 1 over 12 times by the integral from 0 to 12 of f, or in this case, c of t dt, or 82.083 degrees Celsius, is the average temperature of the cup of coffee. Remember, this is the temperature of a cup of coffee from 0 minutes to 12 minutes. In degrees Celsius. So you want to make sure that you're referencing the original problem, referencing units as well. Okay, for C, for the interval 12 less than t less than 20, the average change in temperature of the coffee is modeled by C prime of t is equal to negative 24.55 e to the 0.01 t, where C prime of t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t is equal to 20 and show the setup for your calculations. All right. So this is kind of where you can start thinking of this as like a differential equation. So C of t is going to be equal to an integral. Okay. So we're going to say that this is going to be the integral from 12 to t of c of x, or we're going to call this c prime of x. It's a dummy variable, dx. Okay. So now we need to know what's this value at 12, or what's a value that we could plug into this. And luckily we know that at 12 this value should be 0. But we also know at 12 the cup of coffee is 55 degrees. So we get plus C of 12. Well, C of 12 is just going to be 55 degrees Celsius. Now we can evaluate this integral by plugging in C of 20. So this becomes the integral from 12 to 20 of C prime of x dx plus 55 degrees Celsius. Now C prime, now this is a problem where we're going to punch it into our calculator. So we're going to go to math, F and integrate. 12 to 20 are our bounds. And we are going to punch in our function, which is going to be negative 24.55 second e 0.01 x or over x dx. All right. Now what we're going to have to do is we have to add 55 degrees to that. And in this case, we get a value C of 20 is going to be 40.329 degrees Celsius. So that's the value. Now we want to, oh, looks like we already did it. So this would be our temperature at time 20. For D, we want to actually graph this function. So we're going to go to y is equal to 0.2455, second E, 0.01x times by 100 minus x all over x squared. Okay. Then you're going to go over to graph, and you're going to set your calculator's window to be 12 to 20. So you'll set x min to be 12, and you'll set the max to be 20. Now you're going to hit graph. And what you'll see is the graph is going to look something on the lines of this for that interval. So we are looking for whether the coffee is changing at a decreasing rate or an increasing rate. Or, yeah. So this is asking like, hey, is the derivative or is C prime increasing or decreasing? And because we know C double prime is positive on the interval, and I'll call this 12 and I'll call this 20, then we can make the conclusion that because C prime double prime is positive, then the rate of change in C prime must be positive. So because C double prime of T is positive on the interval 12 less than T less than 20, then the rate of change, the ROC for how would I phrase this? The change in temperature the ROC of the change in temperature must be positive so the change in temperature must be increasing. Increasing. All right. I think that answers that problem. Increasing. Give a reason for your answer. All right. I think that answers it. So now what we're going to do, and we did this in less than 15 minutes. In fact, you want to be spending about 15 minutes on each of these, maybe a bit less. But yeah, definitely 15 minutes for these first two. If you can try to save some time for like going back and checking answers. But yeah. So now we're going to check how our answers compare. And I've got all of the answers for question 1. So question 1, we got -4 degrees Celsius per minute. All right, we got the -4 and we got the degrees per minute. So we get 2 out of 2 points. All right. Now, looking at B, we can see the integral. Okay. So we've got the integral set up. And I said it's equal to, but it can equally be read as approximated by 3 minus 0, c is 0. They kind of did it a bit differently from how I set it up, but we got 3 times by 100, 4 times by 85, and 69 times by 5. And they got an answer of 985. So that gives us the first point. Now for the average value, we got the form of the left Riemann sum, we got the estimate, and we got the interpretation. So, we give us a check here. Actually, that doesn't actually give us a check. We got a check here, we got a check here, and then the interpretation. 1 over 12 times by the integral from 0 to 12 dt is the average temperature of the coffee in degrees Celsius over the interval from time 0 to 12. And we can see that is the average temperature of the cup of coffee from 0 minutes to 12 minutes in degrees Celsius. So I just included units in the answer, and that's never bad. So this would be a 3 out of 3. All right, now on to part C. We get 1 point for the integral. We get 2 points for the initial condition. So we got the initial condition, right? We got the 55 degrees. We got the integral set up. Now, and I believe it's okay for us to change the variable to x and then say c prime of x. Just because of the original setup. All right. And then finally for the answer, we got 40.329. Did we have to give an interpretation of that? The temperature of the coffee at T20 is degrees Celsius. Find the temperature. I think this would score just fine, just leaving that as a number. You don't have to write down a statement. So we would get another 3 out of 3 points. All right. So finally, moving on to D. D is the only one that's worth 1 point, but we can say because C double prime is greater than 0 on the interval 12 less than T less than 20, the rate of change in the temperature of the coffee C prime is increasing on the interval. So based on evaluation. So looking at this, we have the point is earned correctly with the answer and reason reference the sign of the second derivative c. So because we said it was positive, we would have earned the point. A response that uses such as... Okay, so whenever you're doing this, you have to be as specific as possible. You can't say it. So in this case, because we said C double prime, that would score the point. So this, my friends, is how you can get at least a 9 on that first question, 9 points. You want to make sure to be as specific as possible, including your degrees and units. Make sure you answer the exact question that's being asked, and you should be able to do well on that AP exam. I hope y'all will join me for the next video in this series.